This is the second video for the final exam for Math 107. This is a question or several questions on the binomial theorem. The binomial theorem is listed in the reference section. Of course, you have to have an idea on how to use it. So you need to use the binomial theorem to compute 2x minus 5 raised to the fourth power. The first thing you have to do is compute a plus b raised to the fourth power. Then use that binomial theorem, use those results, calculate the coefficients, and then move on to the next part. So I'm going to start with a plus b to the fourth as a review. Okay, here's what you do. I just write it in this following very systematic way. I take the first term, which is my a, and I write it with the exponents counting down, and the b comes next to it with the exponents counting up. So b to the 0 is what would be here. It's 1, so forget that. The next term, a is down to 3, but b has to be up to 1. And the next term, a is down to 2, b is up to 2. Here's another term, a is down to 1, b is up to 3. I put the 1 in, but you wouldn't do it ordinarily. And now a is to 0, which I'm going to leave it out, and then I have b to the fourth. Okay, so it's 4, 3, 2, 1, and then 0 in A, whereas in B it's 0, 1, 2, 3, 4. That's the order of the coefficients. Now remember that if you add the exponents together, they always better equal the power 4. 4, 3 plus 1, 2 plus 2, 1, and 3, and 4. Okay, now to construct the coefficients, I make a fraction in front of each one. The numerator of all these fractions is 4 factorial. That's easy enough. Put that in there. And again, you'll have the sample to look at if you forget. But all right. Now, in the denominator, you put the exponents factorial. There's a 0 factorial here for the, which is 1, of course, for the b, and a 4 factorial because that's what the exponent is on a. Here I will have 3 factorial times 1 factorial. Here I'm going to have 2 factorial times 2 factorial. Then I have a 1 factorial times a 3 factorial, and then again 0 factorial times a 4 factorial. I'm writing all this out in detail so that you have a handle on what's going on with it. Okay, you can see by symmetry that this term is equal to this term, and this term is the same as this term. There's other little shortcuts you can remember, but here it is in all its detail. Right. So now I start evaluating these. Actually, I only need to evaluate one of them because there's another little trick if you can remember it, and that's the coefficient of the first and last terms is 1. So this becomes, all this is 1. And you can see the 4 factorials cancel, the 0 factorial is 1, this is 1. So the last term is 1. The next term has the same value as the power. So here's a 4, a cubed b to the first. Okay. And now I have to just compute this term, 4 factorial over 4 factorial. I will create some room. Okay, 2x minus 5. All right, I'll create some room up here. I have 4 factorial over 2 factorial times 2 factorial. I can count the 4 down to 2 factorial. And in the denominator I have 2 factorial over 2 factorial. Cancel these. Now there's nothing left to do but work out the terms. So I have 4 times 3, 2 times 1. What does it give me? 6. So the coefficient here is 6 times a squared b squared. And now by symmetry I can just do 4 ab cubed, and the last term is b to the fourth. Okay, that is what you're supposed to do for the next problem. And now after that we're going to substitute in for the 2x minus 5. Alright, to substitute I'm going to rewrite what we have over here. A plus b to the fourth is a to the fourth plus 4 a cubed b plus 6 a squared b squared plus 4 ab cubed plus b to the fourth. And now I make an identification. I say a is 2x and b is minus 5. So every place I see an a, I put 2x in parentheses. Every place I see a b, I put minus 5 in parentheses. And that will allow me to work out this. So I have 2x to the fourth. Remember the whole thing. Plus 4 times 2x cubed times a negative 5. That's not subtraction, that's multiplication. The next term is 6, and then I would have 2x squared, negative 5 squared. The next one is 4, 2x times minus 5 cubed, and the last term is minus 5 to the 4th. I'm going to carry this out a little further. So when I have the exponent here of 4, it has to go onto both of these terms. The whole term, 2x, is raised to the 4th power. So 2 to the 4th is 16, and then x to the 4th. The next one is 4 times 2x cubed is 8x cubed, and then minus 5, and all that gets multiplied together. The next one will be 6, and then 2x squared is 4x squared. This is what I see most often, people not pulling that exponent all the way through. And if you use parentheses, you have less of a chance of a problem. Now we have minus 5 squared. Oh boy. Minus 5 squared, I'm going to write this here because I don't want this to be, this is the end of the semester and I don't want to see this problem. Minus 5 squared means minus 5 times minus 5, which is 25. What is minus 5 squared? Now the 2 only goes on the 5, and this is minus 25. Okay, surely you know that by now. Very good. Okay, so this is 4x squared, and here's my 25. And now I'm at the next term, which is 4. There's just a 2x. Minus 5 cubed, you're going to have a negative sign left over. So that's minus 125. The negative sign is going to be gone, and it's 625. Right? The important thing here is keeping these parentheses and always remembering that what you have here are not subtractions but multiplications. This ends up with something like 16x to the 4th. Now I've got minus 5 times 8, which is minus 40 times 4. Whoops, that should be a negative sign there. And as you know, by the time you get done with this, all that nice symmetry that you had with a plus b to the 4th is long gone. Okay. Now I have 6 times 25, oh no, 25 times 4. Okay, there's 600 right there. So that's 600 x squared. And then we have 8 times 125, which is 1,000, right? Minus 1,000. X plus 625. How did I get to 1,000? I multiply 8 times 2 times the 125 give me 1,000. The negative sign is again multiplied in, and you get it looking like this. All right. We need to determine if the following matrix has an inverse. In order for a matrix to have an inverse, the determinant of the matrix, I'll call that A, cannot be 0. So you take the determinant. If you remember the determinant of a matrix, you multiply in this direction, which of course gives me a 0, then you multiply in this direction and subtract. So that's minus negative I squared. 0 minus, what is I squared? I squared is equal to negative 1. You must replace the I squared with minus 1. So minus 1 with that negative sign makes that a plus 1, and so the answer is negative 1. Since negative 1 is not equal to 0, yes, it has an inverse. Okay, it's okay if the determinant is negative. It just can't be 0. This is matrix multiplication, so you're multiplying matrix B times matrix A. Can you do that? Well, B is a 3 by 3, and A is a 3 by 3. Because these numbers are the same, I can multiply them together, and the result will also be a 3 by 3. So I can now make it. Let's see, I better get rid of that. Okay, that worked. To proceed. So for matrix multiplication, you take this first row and you go against the first column. And so B times A is going to give me minus 3 times 1, which is a minus 3, plus 4, and a 0. Fine. Go to the next. I have this against the second column. So I've got minus 3 plus 3 and then 0 times 1, doesn't matter. And in the next column I have 0, 0, 0, so that's just a 0. Now take the second row and go against the first column. 4 times 1 is 4, and minus 1 times 4 is a minus 4. Then 0 times a 2 doesn't count. It's a nothing, no contribution. The next one I have 4 times 1 is 4, minus 1 times 3 is a negative 3, and in the last one I have all zeros. Now I can take this last row to form the last row of the solution and go against the first column. So I have minus 2 plus 4 minus 2. Go to the next column. I will have 2 times 1, negative 2 times 1 is minus 2. Then I've got a 3. Then I have a minus 1. In the next column I have 0, 0, and then a minus 1 times minus 1, which is a plus 1. Okay, so I'm going to work this out. Looks like minus 3 plus 1 is plus 4 is 1, then a 0, 0. Then I have a 0, 1, 0, 0, 0, 1. If you write this on the test, it is minus 1. It doesn't count. It doesn't count. I want to see this work. All right? Now, what is that matrix? It's the identity matrix. When two matrices multiply together and give the identity, they are inverses of each other. So this means that A is the inverse of B and B is the inverse of A. Here's an inverse exponential problem. How long will it take to triple your investment in an account with an APR of 6% that is compounded continuously? What is the formula for continuously compounded interest? It's a word, PERT, APERT. So write that down before you do anything. The amount equals the principal times E, Euler's number, raised to the RT, A-P-E-R-T. Okay, easy enough. What is R? R is your annual percentage rate expressed as a decimal, so it's 0.06. T is time in years. And now you don't know P and you don't know A, but you want to know how long it will take to triple your investment. Your investment is the principal. You want to triple it, means you want 3 times as much in the bank account. All right? You don't need to know the principal. Just leave it that way because it doesn't matter how much you put in, you want to get 3 times as much out. What can you do about it? It disappears from the problem because you can divide both sides. There you go. And now your problem becomes 3 equals e to 0.06t. To solve for t, you need to get t down onto the line here so you can isolate it. And the way to do that is to take logarithms. You could use log or you could use ln. No calculators again on the final, but there are enough numbers around for you to solve these problems. And if there aren't, you don't have to work out all of the numbers, but you do have to work out all of the work. Okay, so I'm going to take the natural log of both sides. That makes the most sense because I have an e, base e. Okay, now natural log of 3 is just a number. This comes out in front as a multiplier. So I have natural log of 3 equals 0.06t times the natural log of e. But the natural log of e is 1. So here's my problem. Natural log 3 equals 0.06t. I want to find t. Divide both sides by 0.06 and there's your answer.